Hello, everyone, and welcome to another episode of The Robots Are Coming. And today I'll be interviewing Professor Xin, Associate Professor of Operations Management at the University of Chicago Booth School of Business. His primary research is on inventory and supply chain management. And before we get started, I wanted to say that we have a Patreon now where you can support the podcast so I can invest it back in the podcast with better equipment, content, and to help with my passion for both technology and public policy. My name is Ken Hin, your host with The Robots Are Coming. Let's get started.
All right, thanks so much for the introduction, Ken. It's great to be here with you. I'm Associate Professor of Operations Management at the UChicago Booth School of Business. My main research is on inventory and supply chain management. More specifically, I design models and algorithms for organizations to effectively match supply to demand in various contexts with uncertainty. I have been actively collaborating with companies, including Walmart, Alibaba Group, and JD.com. For example, my recent work on implementing state-of-the-art multi-agent deep reinforcement learning techniques in Alibaba's inventory management system was selected as a finalist for Inform's 2020 Daniel H. Wagner Prize, with more than 65% algorithm adoption rate. My other research with JD.com on dispatching algorithms for robots in their intelligent warehouses was recognized as a finalist for the Inform's Franz Edelman Prize last year, with an estimate of billions of dollars in savings.
Great, and you're a professor at the best business school in the world, the University of Chicago Booth School of Business. And as you mentioned, you worked on an algorithm that helped Alibaba own a supermarket brand in Tmall Mart. What's the secret sauce behind the algorithm?
Well, the algorithm currently has more than 65% adoption rate within Alibaba's own supermarket brand, Tmall Mart. Let me first provide some background about the problem. Alibaba is China's largest e-commerce platform by several measures, and one of the largest fastest growing online retailer in the world. Alibaba has massive success with their platform business that collects sellers to consumers. In recent years, they have been expanding to establish their own self-operated business. Linwei, now they are managing their own inventory for the online supermarket store. As you can imagine, as a manager of a typical supermarket or grocery, either online or offline, you have to carefully decide how much inventory to stock. Traditionally, many of these decisions are done by humans. Those inventory managers are responsible for up to thousands of products. And I want to emphasize it is a quite tedious process and easy to make mistakes. Not to mention, many of these products rarely have sales, but still takes a non-trivial amount of human time. And furthermore, from demand forecasting perspective, some products are difficult to manage than others. Now, the algorithm take over most of the slow-moving items. Slow-moving items means the products that are important but may not have constant sales. And human managers are only responsible for fast-moving items that they sell every day. Just to give an example, you can think about toilet paper as a fast-moving items that they sell or not on a daily basis, whereas a toilet brush is a slow-moving item that is important to keep in the stock, but that you may not have sales every day. And put in a different way to think about this problem, managing fast-moving items are high value-added activities, whereas managing slow-moving items are low value-added activities. So what we essentially do here is to outsource low value-added activities to algorithms, and humans are only responsible for high value-added activities. So which is the general rule of automation. In terms of the algorithm itself, we use a deep neural network that allows for the use of feature information such as page views, trends on social media, and many other data to generate an inventory replenishment model. We also capture the interplay between retailer and supplier. For example, how would the supplier respond if the retailer places a large order during a lockdown? The model provides an estimation. If the order volume is twice the normal, the lead time would increase by 30% and the fill rate would drop by 20%. More interesting, we have seen additional benefits amid the pandemic. Over the past 2 years, cities in China have partially locked down to mitigate COVID outbreaks. We have observed panic buying, which is not surprising, from human buyers during lockdown, which leads to the so-called bullwhip effect. By contrast, panic buying and the bullwhip effect can be mitigated under all algorithms. The main reason for that is lead time also increase for large orders during major disruptions. When everyone needs inventory, right? When every retailer needs more inventory, those who want more have to wait longer. And so this results in more product sales out. Algorithms are better able to capture the fluctuation in lead times and fill rates during those lockdowns, and therefore eliminates human tendency to panic buying. And for interesting readers to read more about the details, our paper entitled AI versus Human Buyers, a study of Alibaba's inventory replenishment system, is available on my website.
Well, that sounds like very interesting research, Professor Xin, and I'll be sure to check out your research on your website. It seems like there's a lot of opportunity for growth in this area, and there may be a future where we can improve supermarkets across the United States. Where do you envision that?
Yes, indeed. AI right now is used broadly across the entire industry for inventory management, suggesting the model that can be broadly applied to any retailer.
Well, now let's talk about your work with JD.com, where you worked on dispatching algorithms for robots and intelligent warehouses. Could you talk a little bit more about that?
Oh, yeah, sure. For some background, JD.com is a main competitor to Alibaba. So so it's quite different from Alibaba's platform business. JD is well known to managing its own inventories and logistics. They have also largely automated their warehouses and handle their own shipping. Just imagine if Amazon owned FedEx. They offer high quality same-day delivery service. Last year, more than 90% of their orders were delivered within 1 day. So my research which then is about how to manage robots in their intelligent warehouses. And this work was also featured by many media. Just short speaking, we help the company improve the efficiency of their intelligent warehouses by adopting a model of facility management in which workers stay at the stations where robots bring their product to be packed. In a standard warehouse setting, workers or pickers, they rush around, grab and pack product as orders comes in, and this is called a picker to parts model. By contrast, JD uses a so-called parts to picker model, where hundreds of football-sized robots called Kiva runs across fulfillment center floors to bring product from shelf to human waiting to grab and pack packages. And this system can increase productivity, preserve worker safety, and also cut costs. However, one of the main challenges to implement such a model is to solve a complex mathematical problem of which shelf to bring to which packer once every 5 seconds. Specifically, every 5 seconds, the system decides now which robot that are available to pick which product and then transport to which station. The company initially tried to accomplish this by using off-the-shelf AI software to control the robots, but those commercial software proved too slow, and we eventually develop an algorithm to solve this problem very efficiently. And for interested readers, our paper is also available on my website.
Could you remind our viewers one more time what your website is?
My website, so you can Google my name, Linwei Xin, Chicago booth. Then you will see my website.
Yeah, so that's LINWEI space XIN UChicago booth, and you should find Linwei Xin's website, and you can check out his research there. The next question I have is about the future of your research with JD.com with regards to the future of work. Because here in the Silicon Valley, we have a lot of big technology companies, AI, data science, and with your research work, we can start actually advancing a lot of these technology companies. Where do you think we can expect to be in 5, 10, 15, and 50 years?
Ken, that's a great question. So people now are talking about 100% automation. However, we want to argue that 100% automation is not ideal, at least in the near future. Because even the most automated warehouses still need people to conduct oversight, service the robots, and pack unstandard items. And furthermore, back to Alibaba's case, the 100% algorithm adoption rate is not the goal. And in fact, the algorithm will not be taking away all human jobs anytime soon. Because human communication with supplier is still critical. And for example, suppliers may share inside information that cannot be captured by an algorithm. And suppliers may even find it weird if there's no person on the other side of a transaction. And furthermore, product that requires frequent promotion and price changes cannot be easily managed by an algorithm alone because that requires correlation with other business areas, such as marketing. So the bottom line is automation is great, but at the same time, 100% automation is not a goal as well, at least in the near future.
And what do you envision our world to look like in 50 years at the rate that we're going with your algorithm work and the research that you have?
So that's a great question. So you can imagine that automation will become more and more common. I mean, due to various reasons, right? Such as the shortage of labor and the disruption of the supply chain, and eventually automation will become more and more common. So the only question is whether we will eventually reach 100% automation. So I think that's something not happening in the near future.
And is there a way to give meaning and value to human work if this automation approaches, let's say 98%, 99%, it won't reach 100%, but is there a way we can ensure that labor and human lives are valued?
Great, that's a great question as well. So if I think about those robots in JD or Amazon warehouses, so those investments is huge. And in fact, one of the main bottleneck for companies to use robots in warehouses is the investment cost. So for any company that wants to decide whether they would want to invest in robots, they want to carefully calculate their ROI, right? And also those robots are quite expensive. Cut here. So I'm not sure I can answer this question correctly.
Sure.
Yeah.
Well, thank you for the response. That's definitely something that a lot of lawyers and business people will have to start thinking about in the near future. As you know, it won't reach 100%, hopefully, but we'll have to start speaking to workers and managers and all that to ensure that you know,
right,
that things are positive. The next question I have is, what sort of research work are you currently working on, and what are you expecting to work on in the future?
Right now, I'm more working on online fulfillment. So because I'm mainly working with online retailers, so right now my research mainly focuses on how to help them reduce shipping costs. So which is something important to consider. Just to provide an example, like sometimes you place order at Amazon, you may receive multiple packages. So you may wonder why that happened, but that's very common. But that's very common. So that actually doubles or even tripling your shipping cost. And also package means waste. So, for our purpose, we want to reduce the waste and protect the environment. So one of my research right now is to study how those companies can reduce their shipping costs and, in a meanwhile, and still provide high quality delivery service, like same day or 2-day delivery.
What about using different forms of material instead of cardboard, or morphing the material and putting it in a certain way, or putting puzzles together on certain items? What about all those things?
That's a great question. I think right now, I'll just provide an example. So companies like those delivery companies, they have this S pack in their package, right? Sometimes for different product, you may require different amount of S pack. And just imagine if you put too much S pack, there's certainly a waste. And different product may require different number of S pack. So the question is, can you do personalized decisions for different orders? So somehow it's definitely relevant to the environment.
Yeah, making sure that shipping reduces waste is definitely a question that I constantly think about as well, because my parents own a flower shop in their garage, and we ship flowers and bouquets to people. And the deeper question is, how do we package this for this singular shop, and how do we expand this towards a larger population?
That's exactly. And another question is that do we actually lead same-day delivery? I mean, that's a big question. So once you move from 2-day to 1-day, as a standalone, your cost increase dramatically. So I think a big question is, do we really need same-day delivery? I think the answer is yes for some people, but it may not be everyone. So, but right now, what the company they are doing, they are trying to push from 3-day to 2-day and then even to 1-day for broad category of product. So I just wonder, what's the really meaning for that?
That's a question that I think about as well, and I know that a lot of my friends here in the Silicon Valley are working on drones. What about using drones for faster delivery? Has that do you think that cost of buying those drones has worked, and anywhere in the world did it work in China, or is it going to come out here? What's going to happen? Yeah.
Oh, this drones like a big area right now. Zipline is a very successful example. They're running their business in Africa. They are delivering medical supplies such as blood and vaccines by using drones. So the key to their success, in my view, has two main components. One is those products must be highly valuable. So you are doing blood vaccine delivery, not then delivering pizza. And the other component is Africa has poor infrastructure, such that the roads cannot be reached by cars. So in the US market, we need to find such similar examples or contacts to support this business.
There's also another thing that's been working in Berkeley are these little robot machines that will deliver food, and it was a startup that worked out in UC Berkeley. Do you think there's a chance to expand these little wheeled robots that deliver even Amazon packages or food for people?
Okay, so that would require high density first. So the contact like a campus, so it's a great setting to support those sidewalk robots, because you have high density in terms of demand from students, and also you have high density of restaurants on the campus. And so though that California has very nice weather, just imagine in Chicago in February or January, so you may have a lot of snows on road. Then how would the robots overcome that difficulty? That's a question.
Oh wow, I didn't think about that, because we live in perfect weather here, so I see a bunch of robots everywhere. But I assume in Chicago you have to deal with the snow or thunderstorms or something, so that's
right.
Another thing to consider. And it has, and then you worked on algorithms to improve a lot of these supermarkets. Is there a way to improve like the routes of these drones or these robots that deliver to people? Is there a way to find a way to find the most efficient path?
Oh, that's a good question.
Yeah.
I think for those drone and sidewalk robots delivery, the first order question is regulation, and the algorithm are secondary problems in my view. Once you make the
so it's like regulation from legislators, you mean, or
that's right. That's right.
Okay.
And also from technology perspective, like whether the drone can fly enough time, for example. I think the algorithms are secondary problem in my view for those cases.
So for those cases, if let's say some legislator allows for these drones to fly free and allow these robots to fly free, but there might be problems with hitting people or hitting pedestrians or causing traffic errors or something. If that happens, then you would say that the algorithm would come and
yes,
and
that's right.
and
that's right.
has it been done anywhere in the world? Do you see a case study where it's been done anywhere in the world where this is actually the case? You mentioned Africa as one of them, right?
I think Zipline is one of the most notable success by using drone delivery. Right.
Okay.
I haven't seen any other like similar success in that scale.
Mhm.
Right.
So you think it's a matter of scale at this point? It's a matter of putting it in the hands of legislators, having them encourage the use of these items, and we can probably make a more efficient path and make it better tomorrow. Is that what you're thinking of?
I think they are both very important. Like without regulation, there's no there's no business at all. And once you have that regulation, you are approved to fly your drones, you may think about how to scale that business, right? You would need to find a great setting that, like the one in Africa, you deliver supplies and poor infrastructure. All these components can support the scale of the drone business. We need a more concrete example like that.
It's going to be hard to allow for regulation for this because I know, for example, in San Francisco there was a scooter program. You can think of it like people can rent a scooter and start riding around the city, and there were some accidents for some folks in San Francisco, and as a result some legislators banned those scooters. And even on UC Berkeley campus there was you couldn't use certain vehicles. So I'm just worried that if we have these drones or robots or it'll lead to more accidents, and how are we going to account for, let's say, the cost of injury or the cost of lawsuits?
That's a good question, but I don't think I have a good answer to that.
Okay.
So
Yeah, I'll have to think about that. Yeah, I sorry. Yeah.
That's a very good question.
Yeah. And before we sign off for the podcast, I want to hear your career journey from finishing undergrad and why you chose to get a PhD and eventually become a professor, and what were the decisions that you made that led you to becoming the professor at the best business school in the world? Yeah.
So I studied pure mathematics back to my undergrad in China. So at that time, many of my fellow students and friends, they were considering doing a PhD in the US. So I guess I just followed the flow.
Okay.
And then I went to US after getting my bachelor's degree, and I was first studying pure math in a PhD program, and then I switched to operational research, doing a PhD in operational research. You can think about it as more like applied math fields. Yeah. So it's something I still do proofs and still do models, but I end up in engineering school. And then after I got my PhD, my first job was an assistant professor at UIUC. I was in the engineering school. Sure. At that time, and then 2 years later, I moved to UChicago School of Business. But I guess my research the flavors does not change much in the past years. I just has been working more and more with companies. Eventually, I think the research would, so ideally, the research would have impact in practice. So, that's the ideal purpose. So that's why I have been working more and more with companies in terms of validating the assumptions in my model and the possibilities of implementing my solutions in practice.
Sure. As someone who's curious more about operations research, I in high school I came from a mathematics sort of heavy background as well, and the highest math I took at Berkeley was just calculus. So how do I learn more about operations and or besides going to your website and reading your papers, of course, but how would I learn about operations and that kind of research? What journals should I read? What things should I do to learn more? Yeah.
So basically, you can think about operation is you have an objective, right? You have a revenue function or you have a loss function. You want to optimize your decision, subject to many constraints. You may have some resource capacity constraints, so on and so forth. But eventually, you can think about operation is to make daily routine decisions. You optimize your function subject to many constraints. So for undergraduate, you may want to take some courses. So for example, at Berkeley, you have a very strong IOR department who offer those courses. Yeah, that's what I have to say.
IOR. If as someone who's almost out of school and unable to take those units anymore. Do you have any recommendations for self-learning, whether it's a book, whether it's something even easy, like a read for someone like myself, or for an audience who's interested in operations?
And that depends on what's your objective. If you are facing a real problem, an optimization problem, so you may want to look at those related reference specifically tailored to a problem. I would say that really depends on the purpose. If you mainly want to solve this problem, so that's more efficient to just refer to relevant reference. Sure. Just last week, I got an email from one of our past MBA students. So he's running a startup and he's facing an operation problem. So he asked me what are the relevant reference to solve this problem. Yeah. So I guess that's maybe the most convenient way to learn things. You're facing a real world problem and you look at the papers and even ask your professors, for example.
Yeah, I'm actually very curious about this because my parents run a flower shop outside their garage. My dad delivers the flowers. My mom cuts the flowers and puts it together. If we were to expand this into a startup technology company where we create an app or website, how do we expand the single garage into 10 garages out in the Bay Area? And some of the problems that we're facing is, for example, my mom said that she doesn't trust other people to cut the flowers. My dad doesn't trust other delivery drivers to deliver the flowers because they might break. So, and he wants like the tips from the consumers. So how do we optimize that scenario, and how would we walk through like some of the parameters for this specific problem that I'm facing with the startup that I'm working on?
So my first question is that do you have enough demand? Like
yes, that we actually have too many orders to a point where my dad will decline orders that aren't too high in price. So he'll take only, let's say, like a flower order for $200 instead of an order for $50. Yeah.
Right. Okay. So I will think about this as a supply and demand problem. Now you have enough demand. The only constraint is your supply. Like your dad and your mom's, like their capacities for delivery and cutting the flowers. So without increasing your capacity, there's no way you can meet the demand.
Yeah. So we would suggest, like maybe if we were a creative technology company, we would just hire people who are already making flowers, and then that way we can keep up with the demand.
That's right.
And then how do we ensure that the quality stays up too? Like that's a hard operational task. Like how do we ensure that everyone cuts perfectly, everyone delivers properly, because as we expand, the brand for the singular flower shop might
That's right.
yeah. So how do we do that?
That's a very good question. So you can provide trainings, like you hire like 2 people first, you train that, and then you hire more. You ask this 2 person to train other people.
Okay, so you ask them to train other people. Oh, and then how do you deal with the problem of certain stores don't want to make too much money because they want to stay under the poverty line to get food stamps and government assisted housing? How do you encourage more money? I'm not saying that certain stores are doing that, but it does happen. Yeah.
I see. You want what's the question again? Sorry.
How do we encourage these businesses to want to make more money? Because I think a lot of restaurants or a lot of flower shops that I know want to make less money to get government supported like food stamps or housing, right? So they want to make under a certain amount of money. How do you encourage these stores to make more money to and as I start let's say a startup company that hires all these flower shops?
I see. That's a great question, but I guess it's probably beyond operation perspective.
Okay, that is very much beyond operations perspectives. Okay, yeah, that's something that I'm facing because
right.
I want to market a lot more, but my father does not want more demand, and that's something that is very interesting to me because there's just so much more that we can do.
Right. Probably you can convince them if you getting more demand, even your income go beyond this threshold. I mean, so the surplus is still beyond the tax savings, for example.
Right.
If you can, yeah.
Yeah, and okay, and I mean, that's another issue of how do you convince like people to work more and not take more breaks or take less breaks or something. So that's something that I'm looking forward to learning. I'm doing on the fly right now with my parents' flower shop, and now with Berkeley students, we're creating actually a bigger technology company. So that these are the questions I constantly have. And if I'm planning on applying to the University of Chicago School of Business this cycle. Do you have any recommendations for what sort of students are successful, or what sort of students come through at the best business school in the world?
I think you will be have a very successful application. So
Okay.
I can tell.
Okay.
Yeah,
Awesome.
I gotta say I just look forward to seeing you in Chicago next year.
Okay, awesome. Well, I'll submit my application because right now I'm just helping out a small family business and working with Berkeley students on something else. But hopefully we can talk more once we're on campus. So I appreciate the help, and thank you again for having the wonderful conversation. Thank you everyone. Yeah, and thank you everyone for listening to this episode of The Robots Are Coming. Next time we'll have even more great researchers, professors speaking on the topics of things like corporate law, entrepreneurship, and more. So make sure you subscribe to The Robots Are Coming wherever you're listening to, and tell all your friends to do that as well.